Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic, we are going to introduce the next section that describes a systematic approach to solving a system of linear equations. So, in this topic, we will introduce this section and we will give an overview of what will be covered. Up to now, we have seen that the following two problems are equivalent. Finding a linear combinations of vectors in R to the m that equals a target vector v also in R to the m, as well as solving the following system of m linear equations in n unknowns. Now, solving such algebraic equations by hand is difficult at best, and it's tedious and error prone. We are going to introduce a technique that will solve such a system that eliminates the variable names that appear within the equations. This technique will make it easier to solve the problems using by hand, and also it's a technique that can be easily programmed into a computer. So, in the next few topics, we will define matrices, its entries, column vectors, and other issues associated with matrices. We will define the augmented matrix that is equivalent to a given system of linear equations. We will then define possible row operations on a matrix or augmented matrix. We will define the leading zeros in a row of a matrix, the leading non-zero entry of a given row, and the row echelon form. Finally, we will describe numerically stable algorithms that manipulate the augmented matrix to find a solution to the system of linear equations. Basically, this will be Gaussian elimination with partial pivoting and backward substitution to get the answer. So, following this topic, you now understand the purpose of the next 5 topics, and you know that at the end of this sequence of topics, you'll be able to either find a solution to a system of linear equations, or you will be able to determine that no solution exists. Here's the references, acknowledgements, the colophon, and a disclaimer. Cheers!